It's on a scale that's hard to take in. The size of 600 football pitches, this colossal construction site is where a record-breaking tunnel is being built.
How do you carve a tunnel wider than a 5-story building beneath one of the planet's most temperamental rivers? But wait, there's another twist. A deadline, 110 days. Seems impossible, right? Well, no more. Today, we'll unpack how China built the world's largest underwater tunnel in just 110 days. Let's get started. Why was the tunnel needed? Jinan, the capital of Shandong province in eastern China, sits astride the lower reaches of the Yellow River. By 2020, the municipality counted more than 9.4 million permanent residents and over 3 million registered vehicles, according to data from the Jinan Municipal Bureau of Statistics. Rapid urbanization over the previous 2 decades concentrated commercial districts south of the river, while large new housing developments rose on the northern floodplain. Daily commuting between these two zones steadily intensified, and by 2021, the navigation company AMAP's annual congestion index ranked Jinan as the most gridlocked city in China for a second consecutive year. The report estimated that traffic delays were costing the local economy about 15 billion yuan, roughly $2.3, each year in wasted fuel, lost productivity, and delivery disruptions. This could not stand. For decades, drivers seeking to cross the Yellow River in Jinan had only 2 primary fixed routes: the Jinan Yellow River Highway Bridge, completed in 1982, and the Jinan Second Yellow River Bridge, opened in 1992. Both carry a mix of national and provincial expressways, and by the late 2010s, their combined daily traffic volume exceeded 150,000 vehicles, far beyond their original design capacities. During peak holiday periods, the bridges routinely suffered tailbacks stretching more than 6 kilometers, turning what should be a 10-minute trip into journeys lasting well over an hour. Ferries provided an alternative, but were even slower and prone to seasonal interruptions caused by flooding, ice, or strong currents. Local transport authorities recorded that the ferry crossings together moved fewer than 10,000 passengers per day. This was a negligible share of total demand in a metropolis of Jinan's size. Simply adding another bridge was not a realistic solution. The Yellow River in this section is famous for its shifting course and unstable banks, earning it the historical nickname China's Sorrow. Geologists from Shandong University have documented annual lateral movements of up to 20 meters in some reaches, a result of high sediment loads and frequent floods. Any new piers would have to be sunk into thick layers of unconsolidated silt, creating a risk of differential settlement and long-term structural instability. In addition, the Ministry of Ecology and Environment has designated several stretches of the Jinan riverfront as key ecological reserves to protect wetlands and migratory bird habitats. These zones restrict heavy construction and require extensive environmental impact assessments. Urban density on the south bank posed another formidable obstacle. Satellite mapping by the Jinan Urban Planning Bureau showed that the only geologically stable alignments for an additional bridge would have cut directly through neighborhoods housing more than 240,000 residents. Large-scale demolition and relocation on that scale would have been politically and financially prohibitive. Previous attempts to widen the existing bridges had already met resistance from local communities because of noise, dust, and the loss of riverside parkland. Municipal planners concluded that any above-water crossing would either destroy valuable housing stock or require rerouting of major expressways, compounding congestion instead of relieving it. These combined factors, runaway traffic demand, limited and overburdened crossings, geological instability, and strict environmental protections, created an urgent need for an alternative solution. In 2018, the Jinan Development and Reform Commission commissioned feasibility studies from the China Railway Tunnel Group and the Shandong Provincial Transport Institute to evaluate subaqueous options. Their reports highlighted that a shield tunneling approach, buried more than 40 meters below the riverbed, would avoid the shifting silt layers near the surface while leaving the protected wetlands untouched. Cost estimates initially ranged between 6.5 and 7 billion yuan, a figure deemed acceptable when compared with the economic losses from chronic congestion. By 2020, the proposal gained formal approval from the National Development and Reform Commission. The decision to proceed reflected broader national priorities as well. China's 13th five-year plan emphasized the creation of intercity transport corridors to support the coordinated development of the Beijing, Tianjin, Hebei, and Shandong Peninsula city clusters. Jinan's position as a regional logistics hub on the Beijing-Shanghai high-speed rail corridor made alleviating its internal traffic bottlenecks a matter of provincial and national interest. The green light was given. Now came the challenging part: project scope and design. The structure extends 5.4 kilometers from the south bank near Huaiyin district to the rapidly growing northern districts of Jinan. Of this length, 3.6 kilometers run directly beneath the river itself, making the Jinan-Huanggang Road Tunnel one of the longest subaqueous urban roadways in the country. The alignment reaches a maximum depth of about 46 meters, or approximately 150 feet, below the riverbed. The tunnel's cross-section is unprecedented in size, with an internal diameter of 17.5 meters, or roughly 56 feet. It holds the record as the world's widest underwater shield tunnel as of its completion in late 2024. This surpasses the 14.4-meter Rogfast tunnel currently under construction in Norway, and doubles the 7.6-meter bores of the Channel Tunnel linking Britain and France. Engineers selected a circular shield configuration to resist the variable pressures of the Yellow River and to simplify the continuous placement of precast concrete lining segments. The outer concrete wall measures about 1.2 meters thick, capable of withstanding hydrostatic pressures approaching 580 kilopascals. This is the force exerted by dozens of tons of water on every square meter of surface. A key innovation is the tunnel's double-decker roadway. Instead of two separate bores, designers stacked traffic in two levels within the same circular tube. The upper deck carries 3 southbound lanes from the northern new districts towards central Jinan, while the lower deck accommodates 3 northbound lanes. Each carriageway maintains a standard lane width of 3.5 meters, allowing passenger cars, buses, and freight vehicles to travel simultaneously. This configuration minimizes the surface footprint and reduces excavation volume compared with building 2 parallel single-deck tunnels of equal capacity. Structural engineers from Shandong University collaborated with the China Railway 14th Bureau Group to model vibration and load distribution so that traffic on one level does not compromise the stability of the other. Traffic management inside the tunnel relies on an integrated intelligent transport system designed by the Jinan Urban Construction Group in cooperation with Huawei Technologies. The posted speed limit is 60 kilometers per hour, but adaptive LED signage and variable message boards allow operators to adjust limits in real time based on traffic density or maintenance needs. Entry ramps on both banks are equipped with AI-controlled traffic lights that meter vehicle flow to prevent backups within the confined space. Cameras and radar sensors feed continuous data to a central control room where algorithms can detect stopped vehicles or accidents within seconds and automatically trigger ventilation changes or emergency alerts. Ventilation and safety systems are engineered to match the unprecedented scale of the bore. 16 jet fans per kilometer, each capable of moving more than 100 cubic meters of air per second, can completely replace the air volume of the tunnel in under 3 minutes. 27 emergency cross passages, located at 200-meter intervals, lead to elevated walkways protected against potential flooding. These exits connect to vertical shafts that provide independent escape routes to the surface. Fire suppression is handled by a high-pressure water mist system, while thousands of sensors monitor temperature, carbon monoxide, and structural strain in real time. When fully operational, the Jinan-Huanggang Road Tunnel is designed to handle an average of 30,000 vehicles every day, a figure derived from regional transport modeling by the Shandong Provincial Department of Transportation. At peak hours, the facility is expected to carry nearly 3,000 vehicles per lane per hour, easing pressure on the city's two overburdened Yellow River bridges. Municipal planners estimate that the new crossing will cut average north-south commute times by more than 40% and reduce annual vehicle emissions in central Jinan by tens of thousands of metric tons due to smoother traffic flow and the elimination of long idling periods on congested approaches. Safety and environmental measures. Because 3.6 kilometers of the route run directly under the river at depths reaching roughly 46 meters below the water surface, designers from the China Railway Tunnel Group and the Shandong Provincial Department of Transportation treated flood risk and structural resilience as top priorities. The circular lining of the tunnel is 1.2 meters thick and formed from high-strength C60 reinforced concrete. Laboratory tests conducted at Shandong University confirmed that the lining can withstand hydrostatic pressures of about 580 kilopascals. This is equivalent to the force of more than 40 adult Asian elephants pressing on each square meter of wall. This level of tolerance will ensure that sudden surges in river level or seasonal flooding cannot compromise the structure. Emergency evacuation planning was equally rigorous. The finished tunnel incorporates 27 cross-passage exits spaced at 200-meter intervals, each leading to elevated walkways set above the highest recorded flood level of the Yellow River in this section. These passages connect to vertical shafts equipped with smoke-proof staircases and independent ventilation ducts. This means that occupants can escape without re-entering the traffic bore. Fire-resistant doors, rated to withstand temperatures of 1,200 degrees Celsius for 2 hours, seal each exit, and photoluminescent signage, powered by self-charging batteries, guides evacuees even during a complete electrical failure. Jinan's Municipal Fire Brigade conducted full-scale drills in September 2024, simulating multi-vehicle collisions and hazardous material spills to verify that the entire tunnel can be cleared of traffic within 15 minutes under worst-case conditions. Ventilation is provided by one of the most powerful longitudinal jet fan systems installed in any urban road tunnel worldwide. 16 jet fans per kilometer, more than 80 units across the entire alignment, can replace the tunnel's entire air volume in less than 3 minutes. Each fan moves over 100 cubic meters of air per second and is connected to a central control room near Huayin district. Air quality sensors mounted every 50 meters monitor carbon monoxide, nitrogen dioxide, and particulate concentrations. If readings exceed thresholds for road tunnels, the system automatically increases fan speed and adjusts airflow direction. This ensures safe breathing conditions under all conditions. To guard against flooding, the tunnel floor incorporates a continuous drainage channel feeding into 3 pumping stations, each capable of discharging 600 liters of water per second into the city's stormwater network. These stations are backed by redundant power supplies and diesel generators to remain operational during regional blackouts. Watertight expansion joints and double-layer gaskets at every segment connection prevent infiltration from the river above. Temperature and vibration sensors embedded in the concrete lining relay data in real time to a supervisory control and data acquisition or SCADA system, allowing maintenance crews to detect micro-cracking or joint movement long before structural integrity is threatened. Then there are environmental safeguards. The Yellow River near Jinan supports over 160 fish species and protected wetlands, so engineers avoided conventional dredging. Instead, the 4,200-ton Shanhei tunnel boring machine advanced beneath the riverbed, while placing precast concrete linings, disturbing only about 15% of the sediment layer. Roughly 1.6 million cubic meters of excavated material was filtered onshore to capture particles above 0.1 millimeter, with 98% recycled for local road construction. To protect water quality and aquatic life, more than 13 kilometers of floating silt curtains lined the banks, and continuous turbidity monitoring ensured sediment levels downstream stayed within the Yellow River Conservancy Commission's 20 milligrams per litre limit. Noise from machinery was held below 75 decibels, using low-impact slurry pumps and acoustic housings. Mid-2024 surveys by the Chinese Academy of Fishery Sciences reported no measurable decline in migratory species such as Chinese sturgeon. The finished tunnel also reduces emissions. LED lighting cuts electricity use by 40%. Ventilation heat is recovered to warm service areas, and shorter cross-river travel times are projected to lower annual carbon dioxide output by about 20,000 metric tons. So, how did China do all of this? Well, one thing is for sure, it wasn't easy. Construction strategy and timeline. The project was built on an extraordinarily compressed schedule, completing its main civil works in just 110 days. Comparable projects in China, such as the Nanjing-Huaishan Road Tunnel beneath the Yangtze River, required more than 3 years of continuous construction. To meet this deadline, the project team from the China Railway Tunnel Group and the Shandong Provincial Department of Transportation adopted an industrialized strategy focused on extensive prefabrication, precision logistics, and round-the-clock operations. Prefabrication formed the backbone of the accelerated schedule. Approximately 92% of the tunnel's structural components, including 45,000 precast concrete lining segments, emergency walkway slabs, and ventilation duct sections, were manufactured in a dedicated facility in Jinnan's Huayin district months before excavation began. Each segment was cast from high-strength C60 concrete with embedded steel reinforcement, then cured in controlled environments to guarantee dimensional accuracy within 2 millimeters. This off-site production meant that once the 4,200-ton Shanhei tunnel boring machine advanced, installation could proceed immediately without waiting for on-site casting. Just-in-time delivery protocols ensured that no more than a day's worth of segments were stored at the launch shaft, reducing the need for large staging areas and allowing continuous boring. Construction crews operated on 24-hour shifts, split into 3 8-hour rotations, involving roughly 1,800 workers at peak activity. These teams coordinated excavation, segment installation, and support systems so that the shield advanced an average of 35 meters per day. Digital scheduling software tracked every delivery from the prefabrication plant to the riverbank, using GPS and RFID tags to prevent delays. The system resembled manufacturing assembly lines more than traditional civil engineering, a key reason the tunnel's 3.6-kilometer underwater section was completed in just over 3 months. Before the tunnel boring machine could begin its northward drive, engineers had to stabilize the southern bank of the Yellow River to prevent collapse during excavation. Geotechnical surveys by Shandong University revealed weak alluvial soils prone to liquefaction, so workers installed a continuous sheet pile wall stretching 1.4 kilometers along the construction site. These interlocking steel piles were driven 30 meters deep using vibratory hammers, forming an impermeable barrier against river seepage. Simultaneously, dredging operations removed about 860,000 cubic meters of silt and sand to create a stable launch chamber and to lower the local riverbed slightly, reducing hydrostatic pressure on the initial tunnel sections. The dredged material was transported to designated containment sites upstream and tested to comply with the Yellow River Conservancy Commission sediment standards. The weather posed significant obstacles throughout the 110-day push. Jinan's summer monsoon brought heavy rains in July 2024, at times exceeding 100 millimeters in a single day, threatening to flood the launch pit and logistics roads. High-capacity submersible pumps capable of moving 1,200 liters per second were deployed around the clock to keep the works dry. As construction advanced into late September, night temperatures fell below freezing, complicating the injection of grout used to fill gaps between the tunnel lining and surrounding soil. To maintain proper curing and prevent frost damage, contractors heated the grout to a steady 25 degrees Celsius using mobile boilers and insulated delivery hoses. These measures allowed uninterrupted segment installation even when air temperatures dipped to -5 degrees Celsius. Logistics planning extended beyond the construction site. River traffic on the Yellow River remained active, with an average of 150 cargo barges passing daily. To avoid disruption, the project authority coordinated with the Yellow River Navigation Bureau to establish temporary exclusion zones and to schedule dredging and supply barges during low-traffic windows at night. Continuous environmental monitoring ensured turbidity and noise remained within national limits, preventing harm to fish habitats and nearby wetlands. By early October 2024, the main tunneling drive was complete. The crews had shifted to finishing works, such as installing lighting, ventilation systems, road surfaces, and intelligent traffic controls. Despite the extraordinary pace, independent inspections by the Shandong Provincial Quality Supervision Station recorded no structural defects and confirmed that the 1.2-meter-thick lining met design tolerances for water pressure and seismic resistance. The combination of massive prefabrication, precision scheduling, and proactive responses to weather and geotechnical challenges allowed Jinan to inaugurate the Huanggang Road Tunnel on the 28th of November 2024, less than 6 months after the first sheet pile was driven. At the heart of it all is the Shanhei Tunnel boring machine. Built by China Railway Construction Heavy Industry in Changsha and delivered to Jinan by barge, the machine's cutter head measured 17.5 meters across and weighed about 4,200 metric tons, roughly the mass of 10 fully loaded Boeing 747s. Its immense size let engineers carve a full double-deck, 6-lane roadway in a single pass, crucial to finishing the 3.6-kilometer underwater drive in only 110 days. Powering this giant required 7,500 horsepower and 26 million pound-feet of torque, with 12 variable-speed drives enabling precise control through shifting layers of clay, sand and gravel beneath 46 meters of river water. Despite operating under pressures up to 1.2 megapascals, the TBM advanced 16 to 18 meters a day, about double the pace of comparable projects such as Shanghai's Yangtze River crossing. More than 3,800 sensors fed real-time data to an AI-assisted control center, which continually adjusted face pressure and slurry viscosity to prevent soil collapse or flooding. Laser guidance kept the alignment within 5 millimeters, while an erector system installed 72-ton concrete rings every 2 meters to provide instant structural support. Innovations cut downtime to a minimum. Robotic arms replaced worn cutter teeth in under 22 minutes, a third of the normal industry time. A 3-stage slurry filtration system recycled processed water and maintained turbidity far below the Yellow River Conservancy Commission's limits, and thermal sensors safeguarded the river's ecology. By completion, the project generated 43 patents, including fast-hardening concrete and adaptive gaskets for extreme pressures. When the cutter head broke through on the 12th of September 2024, Jinan gained the world's widest underwater road tunnel with a finished internal diameter of 17 meters. The entire 5.4-kilometer project, including approach roads and ventilation, cost about 690 million yuan, or roughly $95 million, a fraction of the per-kilometre expense of Norway's larger but slower Rogfast Tunnel or the Channel Tunnel. Prefabrication of 92% of components, around-the-clock 3-shift operations, and just-in-time logistics allowed this record pace and economy. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now, it's truly unbelievable.